Okay, kids took extra time taking their quiz. So today we're going to be working on use substitution with the power rule, which works for any power other than -1. And if the power is -1, then it's the ln of u. All right. Let's get right to see an example of both of these. I'm going to skip over some stuff I was going to do. And we're going to get right to an example. I'm going to juxtapose two problems, and hopefully you'll see. Look at these two problems. Okay, we're going to do the one on the left first. Oh yeah, you missed a lot. You're not going to know what's going on. Okay, now, we're hoping to rewrite this as some simple expression in terms of u and du that we can integrate. What do you think we should make u? Bottom. And if you're like, oh no, how did she know that? U is usually the inside function. And if you don't have an inside function, just remember that du is going to be the derivative of u. Okay, so the derivative always has one, the degree is always one less. The other thing that would help you know that u should be the x cubed plus 4x is that du will never be in the denominator. Okay, so you want du in the numerator. If you wind up where you rewriting du's in the denominator, you did something horribly wrong. So u is equal to x cubed plus 4x. So that's your first decision. What to make u? Now, before we can rewrite this in terms of u and du, we have to get du. Okay, so du is simply the derivative times dx. So, you know what, I'll write it out this one time. So what would du dx be? Plus 4. And so du, you would get by just multiplying the derivative by dx would equal 3x squared plus 4 dx. And du is really the key to success in use substitution. Before you rewrite everything, you have to make sure that you have in your original problem all the factors of du. So you say, all right, do I have a dx in the problem? There it is. You got it, right? You'll always have that one. I just do that one because, I want some extra factors to look for. But what about the 3x squared plus 4? Do you have that? Yes, you do. It's right here. I have to underline it so kids at home can see. All right, so you have both factors of du. You don't have to put a number in and it's reciprocal on the outside. It's all ready to convert. So now, once you make sure your factors of du are there, you're going to rewrite the integral in terms of u and du. Little by little. There you go. Okay, so we're going to have, when I rewrite an expression, I usually look for the u first. So u is x cubed plus 4x. So you see that you have in the denominator, and it's squared. So that's a u squared down here. Now, so we've replaced the x cubed plus 4x, that quantity squared, but we still have to replace the 3x squared plus 4 times dx. That's your du. You see how that equals du? Okay. So you see, by making the correct substitution, we have a rule to integrate this. Is it the ln or the power rule? Which rule am I going to use? It's the power rule. Because it's u to the -2. It's only if you brought it up and it was u to the -1. If it's just du over u to the first, that will be the ln. So since it's not the ln, you must, before you can use the power rule, you got to bring the exponent up. So we'll be integrating u to the -2 du. All right, power rule. Let's apply it. We came all this way just to find the antiderivative, so don't forget to get the antiderivative. Add 1 to the exponent. What's -2 plus 1? negative 1, and then multiply by the reciprocal, so it's also negative 1. I'll just put a negative there. Let's see. Careful. Now, negative u to the negative 1, that's negative 1 over u. But we got to do one more thing. So we did find the antiderivative. What do we have to do before? Yeah, we got to substitute back in and write our answer in terms of x. So you're given a problem in terms of x. You convert it over to u and du so you can integrate. You get your antiderivative and you switch it back. How lovely. So our answer is negative 1 over, what is it, x cubed plus 4x? Plus 6. Isn't that beautiful? Yeah, because, see, that's the one thing I kind of skipped today. Maybe I shouldn't have. Remember, all you want to do is work it backwards. Like whenever you're integrating, basically someone's saying to you, here's the derivative, what's the function? And we know that derivatives of compositions of functions always have the derivative of the inside. So when you work it backwards, you don't have the derivative of the inside anymore, right? It kind of goes away because you're coming up with the function. All right, so we have another problem over there. What do you think we want to make u this time? It's not a trick question. What's that? So we don't have a rule for that. That was one of our integration formulas, so we're going to have to use u substitution. U is the bottom. Because when you take the derivative, the degree goes down 1, right? So that makes more sense if this is u and that's the derivative, not vice versa. So we'll make u x cubed plus 4x again. This time I'm not going to first get du dx and then du. It's kind of like a wasted step. Okay? We just get the derivative and multiply by dx. So du equals, oh, we did this already, didn't we? 3x squared plus 4 times dx. Once you get du, you take inventory. Do I have the ingredients? Do I have all the factors of du in place in the original problem? Got the dx. Do we have the other factor of du? Yes, we do. So we don't need to multiply by a constant. We've got it. So if you have all the factors of du, what's it time to do? I rhymed that on purpose. It was good. That'd be good to come up with some kind of a little song for that. It's time to do. Does anyone know? I gotta work on that. When you have your factors of du, what's it time to do? Well, before you can integrate, yeah, convert it over to u. All right. Everybody, u equals x cubed plus 4x. Everyone find it in the real problem? Okay, that's just the bottom. And it's just u. Last time it was u squared. This time it's just u. Is this going to be a problem? Not a problem for us. And what about this 3x squared plus 4 times dx? What does that equal? Du. Okay, this time, is it going to be the power rule or the ln? ln. So don't even try to bring it up to make it u to the negative 1. That won't work. Just leave it. Don't do it. What's the antiderivative of du over u? The ln of the absolute value of u plus c. So we're applying a different rule. We can't use the power rule. Okay? So we came all this way just to get the antiderivative. We did it. Now we have one more thing to do. Yep. Just convert it back to x's. Plug in for u. It's the ln of the absolute value of x cubed plus 4x. Let's see. Fun, right? What I like to do, if you have yesterday's notes, I was thinking maybe because these didn't have you didn't need any constants for DU, and I know with the homework we have some like that. So I was wondering if there's one of the class problems from yesterday that we didn't do that you would like to do. One of the class problems. We did some of them. I don't remember which ones. Like if you gave me a number, we could go through it. There's the classwork and then the homework. What's that? Anyone have one from the classwork yesterday? Do I have like the wrong thing? Okay. Anyone in particular? Yeah. Number 6. Oh, good. I don't have to move the board. Okay, guys, we're trying number 6 from the classwork from yesterday. Okay, so we have this integral. I'm just going to write it over. No, let's bring it over here. Okay. All right, so this is not something I have a formula for, so I'm going to have to use U substitution. I can't break it up. First thing you have to do is decide what are you going to make U. Oh, wait a minute. You know what I want to do first? You're right. You see how there's a constant multiplier here? Whenever you have one of those and your homework problems have a lot of them, just pull it out right from the beginning. Let me just pull that right out of there, or else it's going to confuse you. So let's say we have x squared over 5x cubed plus 3 dx. That's better. And that 60 is just going to come along for the ride until we're done. So, what do you want to make U? The bottom, right? So, U equals 5x cubed plus 3. What's the next thing I need to find? DU. Very good. DU is the key to your success. It is. Did you just flash me a gang sign? Don't do that. I don't approve that. So what's DU? 15x squared. Ooh, she remembered the dx. Okay. You did. Where did what? Because going from u to du, you're taking the derivative, multiplying by dx. So now you have different factors of du. You always have the dx, all right? So that's no biggie, no shocker. You got your x squared, right? But, yes, ma'am. Nope. Where, isn't there what? Oh, don't go the wrong way. Yeah. Yeah, you see how we're missing? You have to have, before you convert it over to u's, you have to have all factors of du. So I'm missing a 15. So that's no problem. I'll put a number, that 15 up here. But now you have to divide outside by 15, or else you change the problem. That 15 wasn't there to begin with. If you put something in there that wasn't there to begin with, you need to multiply by its reciprocal. Okay. So now on the outside, what do we really have? A 4. And let's rewrite it. Once you have your factors of du in place, it's time to convert it over to u. Where is the u? At the bottom, right? So I'm going to put a u down here. And it's just u. It's not like square root of u or u squared. It's just u. And then what am I going to replace the 15x squared dx with? U. Is this power rule or ln? ln. So we actually take the antiderivative. We find it. It's 4 ln of absolute value of u plus c. Oh, okay. Do you see how we first we made sure we had the 15, so and then we could rewrite it. The 15x squared dx we replace with du. That's what it equals. The 5x cubed plus 3, we replace that with u. Yes, because it's got to be there. Yes. It has to be there before you can integrate in terms of u. You have to have the u there. But you gotta get it and forget it. All right? All right, and then we have one more thing to do. Switch it back to x's. So we have, so our final answer is 4 times the ln of the absolute value of 5x cubed plus 3 plus 6. I didn't put a summary on yesterday's notes, did I? I had a really good one. Oh well. Kind of makes me a little sad. Wait a minute. Well, I had one. I don't know why I didn't print it. You think it'll be okay? I'll have to type this. I'll type this up again. I'll type it up again so you can do it with me. Yeah. Oh, on the homework? Okay. Let me stop this. Oh, you know what? Let me fill in this because the kids at home have it. And then I'll help you. To anti-differentiate u to the n, you must have du. You can't use the power rule on u to the n unless you have du. What's the only value of n for which you cannot apply the power formula? -1. If you do have u to the -1 du, what is the antiderivative? I know you don't have this. I got to give you a copy. ln of the absolute value of u plus c. When you integrate a fraction, you always want to check if the numerator is or can be made to be the derivative of the denominator. Because if it is, you'll have a du over u. Up. Derivative of the denominator. And in order to integrate a function of u, all factors of du must be present. If you need to multiply inside the integral by a missing constant factor of du, then you multiply the outside by the reciprocal. Once you have du and apply the formula, what do we do with du? Ah, forget about it. That's funny. Yeah.
Number 6.
Yeah.
You have like
Let me just hit that.